Dear esteemed colleagues, hi. I'm speaking to you from the safety of my home. I'm inconsolable that I wasn't able to make it to Glasgow and to iPres this time and to meet you all. But here's the paper access quality metrics for NetArt in video form. This was made by Xiao, an independent researcher that joined Rhizome for this work as a volunteer, myself, and Lyndsey Jane Moulds, the software curator at the time for Rhizome. This is our logo. And just a quick recap, Rhizome was founded in 1996. The ArtBase collection exists since 1999 and today references more than 2,200 artworks, digital art, NetArt, software art. And for more than 800 artworks, Rhizome holds at least one copy or variant, and we want to make them accessible through the ArtBase on the open web. I want to show a few works just real quick. This is the CD-ROM game Smarty from 1996 by Theresa Duncan. This is Starry Night by Alex Galloway, Mark Tribe, and Martin Wottenberg from 1999. This is a interface to Rhizome discussions of the time. This is a Java applet that runs in a full-screen browser here and interfaces with a legacy web server that holds the data. Bodies Incorporated by Victoria Vesna, 1996. It's a VML piece, and yeah, I thought I picked that because I've seen another VML work on the program, and I really love VML. So you see, this is all fine here. So we are running emulation as a service, which acts as the front end for a lot of the works that we keep. Web recorder tools for network preservation and web archiving, LXC for server containers, and of course also static file storage where data is just delivered to users via HTTP. And no matter what the work might be, a CD-ROM game or a Java applet or some complicated VML NetArt piece, there are some common issues. The work could just be incomplete, we don't have all the data, or they have become difficult to access because they are made for a software environment that users don't have access to anymore, or the emulation environment that we provide is not really fit for the task, has maybe some gaps in its software equipment. So users can browse around in the ArtBase, but they are at the moment not really prepared if the work that they want to see exists in a copy that works really well or a copy that has things missing or just doesn't function very well in the environment it is currently placed in. So that means we are trying to manage user expectations, but we also want to use the representation of access quality to plan and prioritize preservation actions, of course. Okay, so in Rhizome's view of the world, an object, that is, an artwork, is composed of artifacts, that is, data at rest. And that data is put into a performance environment, and only then the object appears. Otherwise, it's just like gobbledygook on some remote computer. So this time, I want to focus on the performance part here, because I believe artifact completeness is probably something that is well understood here. So the performance of an environment, or the quality of an environment, is expressed via its capabilities. To understand the capabilities, data needs to be collected in a certain way about software. And I would argue that it should be collected from a preservation perspective rather than from a bibliographic perspective. And I quickly want to show what I mean by bibliographic perspective. So this is the Wikidata item for Microsoft Word. Someone thought it was funny to remove the label, apparently. And I can see here there's like interesting information that it's a word processor and so forth. But here's the publication date, 1983. This is just when the first version of Word was released. Here is the readable file formats. I'm very, very sure that Office Open XML couldn't be read by the version of Word that was released in 1983, or the Microsoft Office XML formats. And here we also have writable formats, which are probably mentioned here to facilitate some migration workflows. I don't know. And here are some software version identifiers, which are all nice, but they don't point to any particular version. They don't say what version is it. We have here external identifiers, which also don't point me to the exact binary, to the exact installable version of Word that has particular capabilities to like read or write certain types of files. So this is more general information that concerns Word as a series rather than particular executable and installable binaries that actually have these particular capabilities. So for the thing we want to do, it is kind of not very useful information. So taking these ideas into account and working with some concepts that are included in EAS actually, we came up with a different model to record that information. We have artifact identifiers. Artifacts might be just a set of files, disk images, web archives. And via Siegfried, we just record any data format that's detected inside an artifact. We don't count how many, just that there is at least one occurrence. Then we have machines. They are referenced by their EAS UUID. And yeah, of course, they have a QID in our own wiki base. And machines contain software. Software might be a software bundle or like the final software that is installed. And software just handles data formats for our purposes. So that means it does whatever is required of that software to perform artworks. And they can be installed together on a machine. The variant then, which is the actual point of access, is the combination of a machine with one or more artifacts. And now you can kind of probably understand that there might be matches in between here, between the machine and the artifact, and you can see like what are the differences here. This is curatorial information because this is consciously put together. This is not something that just happens by itself. In addition to that, some manual information is needed, mainly for plain text, data formats, markup languages, and scripting languages, because users have a lot of freedom to express themselves within these languages, and they're not very strict. So HTML written in 2020 registers as HTML. And Netscape 3 from 1997 advertises, I can work with HTML, still wouldn't work. Then there are unknown data formats, which is quite common in digital art. Artists might have used some software that was not very popular, that was just used within a certain community, or they make their own software and come up with their own data formats. And we don't actually have the capacity to create matching rules for these data formats to be detected automatically. So we would rather annotate, because it's also not so likely that they appear in many different places. There's also the issue of context-dependent performance, so a piece of software might handle a certain data format really nicely when installed on its own, but maybe in interaction with other software, some glitches appear, it doesn't really work anymore. And then finally, we need to look at the relevance of a certain data format for the access quality of a variant. Because it might be that an artist delivered the description of their work in Microsoft Word format, but that description is not really meant for users to be accessed. So we would then downgrade the relevance of the Microsoft Word format for a particular artwork. On the other hand, if we would make an exhibition of the best descriptions that Rhizome ever received, make a different variant, a different access point into the same artifact data, but with another curatorial and technical focus, we would grade the Word document as very relevant and the actual artwork as less relevant. So this is how we would handle curatorial overrides. A variant could contain information that there is a particular data format in there and that a certain data format is handled in a particular way. Locating this information in the variant makes it possible to update information about artifacts and software automatically without losing this curatorial information. So this is a flattened table that we can generate with a Sparkle query. It's kind of like the example that I just talked about. There are two different variants. They use the same artifact with the same artifact composition, but they are performed by different machines which have different capabilities. So the support for the data format can be inferred, and for the unknown data format, the value is added manually. And finally, it is weighted with a relevance score that is also added curatorially. You see in the first variant, the Microsoft Word file has low relevance, and in the second variant, it has high relevance. So here, this is how this looks in Rhizom's own Wikibase. Information about software and machines and artworks and their composition is all saved in the same repository. This describes a machine, so an emulator that we can use, running Windows 98 with a software setup that would be typical from 1998 to 2000 maybe. It is referenced by its EAS ID, and it contains a bunch of software. I want to quickly go to Netscape Navigator 4.79 for Windows. Here is a list of the data formats that it actually supports, that were observed in experiments. And this is the software ID that EAS generated. So this version of Netscape is contained on a virtual CD-ROM that we can inject into several other Windows versions maybe and install it there too. Currently, this is still work in progress. And before fully releasing this, we also want to take into account the completeness of the artifacts, as mentioned at the beginning, software release dates, and software performance capabilities. At the moment, we are really working with data formats and can a software like render it. There are other things that are very important too, for instance, like can this browser still open arbitrarily sized pop-up windows? Can it render certain types of form elements? Does it display scroll bars? Does it have a tabbed user interface? All of this can be very particular for the NetArt use case, of course. And here I just want to give a quick insight into how this performance information is observed. This test series was done by the archivist Mona Ulrich, who ran different browsers in different browser versions in different operating systems, and using specimens from our collection to check if they are displayed correctly, if the GIF animations play too fast, and so forth. So this data also needs to go into ArtBase, of course. Okay, thank you so much. That's it. This presentation focused on the data model part of the work and the reasons for why we came up with that data model. If you are interested in the exact calculations that we want to use to compute a access quality metric score for each artwork, I would ask you to look in the paper. This is really like the biggest contribution by Xiao that we received here. Yeah, thank you so much. Get in touch, write us emails if you're interested in further discussion. And again, I'm so sad I'm not there. See you soon.
Thank you.